I'm Miss Peg, and today I'm going to show you, pause. Hi, I'm Miss Peg, and I'm going to tell you a little bit about polynomials as an introduction to adding, subtracting, multiplying, and dividing polynomials series. So first we need to define what is a polynomial. A polynomial, and here's the book definition, a finite sum of terms in which all variables have whole number exponents and no variable in the denominator. This meets a very specific standard here in the Florida Common Core Algebra 1. I underlined a few of the terms here because I want to explain a little bit further what this means. Now, a finite sum means, even though it says sum, it can be put together by add or subtract. And what that means is you're going to see a set of terms in which here we have 3 sets of terms. And each of them is separated by either a plus or a minus. So I have the first set, the second set, and the third. So there's 3 terms here. So it's a finite sum of terms, here's my terms, in which all the variables have whole number exponents. Now remember, the exponent is here. It's the power that any particular number or variable or base is what it's called. This is our base, and our exponent in this case here is the exponent 2. So we would say this is 3x squared. Well, when you have whole number exponents, that means you cannot have a fraction or a negative here in the exponent. It has to be a whole number, a 2, a 3, a 4, a 7, okay? And also, there's another qualification, and there has to be no variable in the denominator. Now here, we have no fraction parts, so we don't have to worry about that. And you will see that again in another video explaining a little bit more about fractional parts when we see polynomials and how to deal with this. I'm going to erase a few of the things that I have put on here to tell you about the parts of this polynomial. Now, like I said, we have the first term, the second term, and the third term. And there's a few key things you need to know. For an example, this last term here. This is called a constant. The reason this is called a constant is that it does not change or vary. There is no variable attached to the constant. You'll recognize a constant because it's just a number. It doesn't get that much simpler. It could be a whole number, it can be a decimal, and we don't necessarily use fractional parts in polynomials. Again, we'll be talking about that part in another video. The important thing to remember about a constant is that there is no variable attached. So what if you do have a variable attached? Okay, let's move on over. For an example here, you have 2x, 2 times a variable x. This also is a term where 2 is your coefficient and x is your variable. A variable is an unknown number. It's holding a place. If I told you that x was the number 3, you would say 2 times 3 instead of x. At this point, we actually don't know what x stands for because we have not solved for it. So we just call it 2x. When we come over to here, this is actually called our lead term. And the reason I call this the lead term is that it is the front runner in the polynomial. It's the first one on the list of terms that are being added or subtracted here. What makes this a lead term is actually this exponent right here of 2. So we still have the 3x like we saw here in our second term. However, with the addition of this 2 for an exponent, that means we are going to place this term out in the front of our polynomial. What I mean by that, for an example, is if I had 2x plus 3x squared minus 8. The same polynomial, but written in a different way. Actually, this would be the wrong way to properly write a polynomial because we have something called standard form. Standard form tells us that we must put our terms in order from the greatest exponent down to the least exponent, and then all of our constants come last. That's why in this example, our coefficient of 3 is being multiplied to our variable of x that is being squared. Since this x has a power of 2, it comes out in the front of the polynomial and is written with this term first. Then we would follow that in descending order from greatest down to least. Now, there's a special situation here that you may not know about. I'm going to pull this 2x out here to show you. So if I have 2x, what is the exponent on this x? Well, actually, there's none written, and that's correct. You could say there's nothing there. However, it's almost like assuming if I just had the variable x and I wanted to know the coefficient, it's not always written, but we assume it to be a 1. 1x is the same as x. We use that same strategy here when we have powers and exponents. If there is none written, we assume it to be a 1. That helps you to know in which order these come in. So you have an exponent of 2 to an exponent of 1. These are attached to our variables, to our constant, which now has no variable. This polynomial was correctly written in standard form. This polynomial would not have been correctly written in standard form because this exponent value is smaller than this exponent value. Standard form tells us they have to go from greatest down to least, constants being last. This is a very brief overview of what a polynomial is and a few of its parts. Again, it's the sum, which could be plus or minus in this case, of a set of terms, term 1, 2, and 3. They have whole number exponents, a 2, and technically here a 1, but we don't see it. And there's no variable in the denominator. In this example, we don't have any denominators. You will see that in a later video, what to do if you have a variable in the denominator. Thanks.